Welcome back. Today I will see some interesting example of reducibility and irreducibility test for as a shortcut trick so that you can solve any question very easily. At first I will see what is the mod p irreducibility test. Let p be a prime number and fx in zx with the condition degree of fx greater than equal to 1 and f bar x be the polynomial over zpx obtained by reducing all coefficient by modulo p, and if degree of f bar x equal to degree of fx, then we can tell easily f bar x is irreducible over zp, and if f bar x is irreducible over zp, then we all of us know fx is irreducible over q. That means by mod p irreducibility test, if we can to find one prime number p for which the polynomial be irreducible, all of us know this theorem. Today I will see actually this theorem to understand in better way how we will solve one question by this theorem. In my previous video I have also seen this theorem and also I have introduced some example based on this theorem. Today I will also introduce one more example, because if you understand this theorem in better way, then you can easily solve any question, and this theorem actually very important for higher study. As for example, consider Hx equal to 7x cube minus 5x square plus 2x plus 10. Here the question, here I have introduced this question because actually I will say we all of us know by mod p irreducibility test, if any polynomial reducing by modulo p, if this polynomial, if degree of original polynomial and reducing polynomial is same, and if this polynomial means the reducing polynomial is irreducible over zp, then we can tell easily fx is irreducible over q. Here h is equal to 7x cube minus 5x square plus 2x plus 10. Notice hx belongs to zx and degree of hx equal to 3, which is greater than equal to 1. If we consider p equal to 2, obviously h bar x would be x cube plus x square. Here degree same, so we can apply mod p test. Notice since here have no constant, so obviously h bar 0 equal to 0. That means since here for this polynomial it has a root, that means mod p test would be fail. Then my question, which type of prime number we can choose? For this, since here the constant term is 10, 10 means we can write this as 5 times 2. Okay. So if we choose p equal to 5 or p equal to 2, then definitely the constant term would be vanished. And if the constant term be vanished, then obviously it has a root. So we cannot choose the p equal to 2 or p equal to 5. That means we have to choose other prime number. For this prime number, obviously it has a root. This is the shortcut trick. If we consider p equal to 3, then For this, consider p equal to 3, then h bar x would be x cube plus x square plus 2x plus 1. Notice here degree of h bar and degree of h be same. So we can apply mod p irreducible test. Notice h bar 0 equal to 1 and h bar 1 equal to 5, which is congruent to 2 in mod 3. So in mod and h bar 2 equal to 17 and 17 in mod 3, this is reduces to 2 in mod 3. So in mod 3 h bar has no root. Since in mod 3 h bar has no root, so the polynomial h bar x is irreducible. Over Q, since it has no root in Z3. I hope my all viewers have understood this is okay. Oh well. I hope till now my all viewers have understood how we have to solve mod p irreducibility test. How we have to choose the prime number for which mod p irreducibility test would be satisfied. Converse of mod p irreducible test is not always true. As for example, consider fx equal to x to the power 4 plus 1. Here notice degree of fx equal to 4, which is greater than 1. And fx is irreducible over q. Why fx is irreducible over q, I will see few minutes later. But for every prime p, f bar x, for every prime p, f bar x would be obviously x to the power 4 plus 1. This is reducible. I will prove this is fx equal to x to the power 4 plus 1. We all of us know why fx equal to x to the power 4 plus 1 is irreducible. For this, here I will use the Eisentiens criteria. I will use if f of x plus alpha is irreducible for all alpha, then that implies fx is irreducible over q. We all of us know. For this question, here I have chosen alpha equal to 1. Then f of x plus 1 would be x plus 1 to the power 4 plus 1, and x plus 1 to the power 4 means x to the power 4 plus 4x cube plus 6x square plus 4x plus 1, that means that imply x to the power 4 plus 4x cube plus 6x square plus 4x plus 2. Here I will choose for this equation the prime p equal to 2. Notice 2 divide 4, 2 divide 6, 2 divide 4, 2 also divide 2, but 2 does not divide 1. Also 4 does not divide 2 square means 4 does not divide 2. So here f of x plus 1 be irreducible over rational number. But fx equal to x to the power 4 plus 1, this is reducible in ZP. Why this is reducible in ZP? For this, if we consider as for example f5, then in f5 we can write 1 is congruent to minus 4 in modulo 5. Then x to the power 4 plus 1 is equal to x to the power 4 minus 4, and x to the power 4 minus 4 means obviously this is imply x square plus 2 times x square minus 2. Finally, for all prime p, we can factor x to the power 4 plus 1 such type. So, x to the power 4 plus 1 is reducible over all prime p, but this is irreducible over q, and this example is very important example for higher study and also for deep knowledge. Okay, my next example I will see is the polynomial x to the power 4 minus 2x minus 1 is irreducible over q. For this, here also I will use the Eisentiens criteria. If f of x plus alpha is irreducible over for all alpha, then we can tell fx is irreducible over q. For this, consider alpha equal to 1. Then f of x plus 1 equal to, similar to before, this would be x plus 1 to the power 4 minus 2 times x plus 1 minus 1. And x plus 1 to the power 4 means obviously x to the power 4 plus 4x cube plus 6x square plus 4x plus 1. Here 2 times x plus 1 means 2x plus 2 minus 1. And this is equal to x to the power 4 plus 4x cube plus 6x square plus 4x plus 1 minus 2x minus 2 minus 1. That is equal to x to the power 4 plus 4x cube plus 6x square plus 2x. Here 1 would be cancelled minus 2. Here consider p equal to 2. Notice 2 divide 4, 2 divide 6, 2 divide 2, 2 divide minus 2, but 2 does not divide 1. Also 4 does not divide 1. So by Eisentiens criteria, f of x plus 1 is irreducible over q. And since f of x plus 1 is irreducible over q, that implies f of x is irreducible over q. I hope my all viewers have understood it is. Okay. So I will see one example. X to the power 4 plus x cube plus x square plus x plus 1. I will say this polynomial is irreducible in z to x. Here this question is very important. Actually this type of question very conceptual. We all of us know root test only applicable for only degree 2 and degree 3 polynomial. But here degree is 4. So in z to x, at first check the root. F0 equal to 1 and f of 1 equal to 1 in z to x. That means obviously in z to x this polynomial has no root. But since the degree of the polynomial is 4, which is greater than 3, so by root test we cannot guarantee this polynomial is reducible or irreducible. We can express this polynomial, since degree of polynomial is 4, we can express this polynomial as a product of 2 degree polynomial x to the power 4 plus x cube plus x square plus x plus 1. We can write this as x square plus ax plus b times x square plus cx plus d. Now calculate, obviously this is equal to x to the power 4 plus a plus c times x cube plus b plus ac plus dx square plus ad plus bc times x plus bd. Now compare both sides. By comparing, I will get BD equal to 1, AD plus BC equal to 1, B plus AC plus D equal to 1, A plus C equal to 1. Okay? And by BD equal to 1, this imply B equal to 1 or D equal to 1. Means from this expression I have got B equal to 1 and D equal to 1. Just put the value here. Then I will get AC equal to 1 minus 2, that means minus 1. Since I have got AC equal to minus 1, that imply either A equal to minus 1 or C equal to 1. Or either C equal to minus 1 or A equal to 1. If we choose A equal to minus 1 and C equal to 1, then that imply here A plus C equal to 1 given. But here I have got A equal to minus 1 and C equal to 1. Just put the value, then minus 1 plus 1 equal to 1. That means 0 equal to 1, and this is not possible. So by this expression we can tell we cannot write this polynomial as a product of two irreducible polynomial. So obviously this polynomial is irreducible in Z2x because we cannot write this as product of two irreducible polynomial. Okay. My next question similar to before. Now I will see fx, which is written as x to the power 4 minus 2x cube plus x plus 1. I will see fx is irreducible over q. How this is irreducible over q? Notice here degree of the polynomial is 4. Consider the function is reducible over q. For this, consider fx is written as product of two irreducible polynomial. Consider this is x square plus ax plus b times x square plus cx plus d, and that imply x to the power 4 plus a plus c x cube plus ac plus b plus d x square plus ad plus bcx plus bd, and this is equal to fx means x to the power 4 minus 2x cube plus x plus 1. Just compare both sides, then I will get a plus c equal to minus 2, ac plus b plus d equal to no x square term, that means this value would be 0, ad plus bc would be 1 and bd equal to 1. Equal to 1, that imply either b equal to 1 and d equal to 1 or b equal to minus 1 or d equal to minus 1. That means both case b equal to actual d. And b equal to, if b equal to d, then that imply ad plus bc equal to 1. If b equal to d, then that imply ab plus bc equal to 1, then that imply just common b part, b times a plus c equal to 1. But since I have got a plus c equal to minus 2, just put the value, then I will get minus 2b equal to 1, that imply b equal to minus half. But here of the polynomial belongs to zx, but I have got coefficient is rational number, belongs to rational number. This is cannot possible. So by this expression we can tell we cannot write fx as a product of two irreducible polynomial. That means obviously this polynomial fx is irreducible over q. I hope my all viewers have understood this is clearly. Okay? Well, next example, actually this type of concept is very important. So I will do one more example. Fx equal to 3x to the power 4 plus 9x cube minus 7x square plus 15x plus 25. I will say fx is irreducible over q. For this, since here I will apply mod p test, for this I will consider p equal to 2, then f bar x would be x to the power 4 plus x cube plus x square plus x plus 1. And notice here degree of fx and degree of f bar x are same, so we can apply obviously mod p test. Notice f bar 0 not equal to 0 and f bar 1 also not equal to 0. But since here degree of the polynomial is greater than 3, so by this test we cannot tell is this polynomial is reducible or irreducible, because root test only applicable when degree of the polynomial is either 2 or 3. Since here degree of the polynomial is greater than 3, that means we can write obviously this polynomial as product of two irreducible polynomials such type x to the power 4 x cube plus x square plus x plus 1. We can write this as x square plus ax plus b times x square plus cx plus d, and that imply x to the power 4 plus a plus c times x cube plus b plus ac plus d x square plus ad plus bcx plus bd. Then I will get a plus c equal to 1, b plus ac plus d equal to 1, ad plus bc equal to 1 and bd equal to 1. bd equal to 1, that imply b equal to 1 or and d equal to 1 either. Similar to before, or b equal to minus 1, d equal to minus 1. That means both case b and d are same. b equal to 1 and d equal to 1, that imply ac equal to minus 2 and ac equal to minus 2 imply in mod 2, this is congruent to 1 in mod 2. And ac equal to 1 imply either a equal to c, a equal to c equal to 1. Then if a equal to c equal to 1, here I have got one condition, a plus c equal to 1. Just put the value, then I will get 2 equal to 1. But this is not possible. 2 equal to 1 not possible. So here similar to before, we can tell we cannot express this polynomial as product of two irreducible polynomials. So we can tell obviously fx equal to 3x to the power 4 plus 9x cube minus 7x square plus 15x plus 25 is irreducible over q. I will stop here. In my next video I will discuss this topic also, because this topic is very important for higher study, also for competitive exam. So at first I will highly recommend you, please see today's video with pay attention. And if you have any comments, then do comments in comments box. Okay? See you soon. Stay safe and stay positive always. And don't forget to do subscribe my channel for more videos. Thank you so much.